Right, grade 11s, welcome to another series of iCamp lessons. Today we'll be looking at a Limpopo provincial government paper. It's a practice assignment for grade 11s, which is May. So this is a good preparation for your June exams. So let's look at question 1. So in this question, we are given that in the figure below, P, Q, R, and S are 4 points on the Cartesian plane. As it can be seen, we have a Cartesian plane with 4 points, P, Q, R, S. And then we are being told the coordinates of P, the coordinates of Q, the coordinates of R, and the coordinates of S, right? So the first question is that show that PR, right? Show that PR, so this would be your PR. So if we are being told that we must show that PR, so this will be PR is equals to QS, right? So we are being required, or we are being asked to show that these lines are equal, right? In order for us to do that, so this is going to be 1.1. In order for us to do that, we are going to use a distance formula, right? So if we use a distance formula and we prove that the distance from P, the distance for PR is equals to the distance for QS, then we can conclude that these lines are equal because their distances are equal, right? So we are going to use a distance formula, right? So your distance formula is usually given by your D is going to be the square root your x2 minus x1 squared plus your y2 minus your y1 all squared, right? It means that we need the coordinates of x1, x2, y1, y2, right? So how we are going to do that, right? How we are going to do that, we are going to use the coordinates that we have. So we are going to start by PR, right? So we are going to start by PR. So we can just write that for PR, right? So for PR, this is what we're going to do. Remember, PR is going to be your P, and you have 0 and 3, and for R you have 2 and negative 3, right? So essentially it's gonna be easy if you call this your x1, your x2, right? And then this is going to be your y1, your y2, right? So check the consistency here in how I name my variables. So now I'm going to say PR is going to be the square root, right? So now what is my x2? My x2 is going to be 2. What is my x1? My x1 is going to be 0 all squared plus what is my y2? My y2 is negative 3. What is my y1? My y1 is minus 3, right? Squared. So what I'm going to have now, I'm going to be left with PR is going to be your 2 minus 0, it's going to be your 2 squared, plus what is minus 3 minus 3, it's minus 6 squared, right? So then from here I'm going to say I'm going to have my 4 plus what is my negative 6 all squared. Remember this, the negative is inside the bracket, so it's everything squared. It's going to be 36. Now I have PR equals to your root of 40, right? If you like, you can stop here but since they did not specify that we must not use a calculator, so we can just press your calculator, and your calculator is going to give you a simplified answer for square root of 40, which should be your 2 root 10, right? It's going to be your 2 root 10 units, right? So that's the first one for PR, right? That's the first one for PR. Now let's look at QS, right? So now we want for QS, right? So in order for us to find QS, we are going to write the coordinates of Q. So Q is your 4, 1, and S is going to be your -2 and -1, right? So we do the same thing here. So this is going to be your x1, your x2, and then this, this should be your y1, right? And then this is going to be your x2, y2, right? So now let's find QS. So QS is going to be, remember we are still using the distance formula, right? So what's our x2? So x2 is -2 minus x1, which is -4 squared, plus -1 squared. So now you have your QS, which is equals to so -2 minus 4 is going to be -6 squared plus -2 squared. So your QS is essentially your 36 plus 4, and QS is equals to, this is going to be equals to your root 40. And remember what we said, root 40 is the same thing as 2 root 10 units, right? And therefore we can see that QS, right? QS, this is QS, right? So we can see that this is indeed equals to this, right? And therefore we can conclude that therefore your PR is indeed equals to your QS. Why? Because they are both equal to your 2 root 10 units, right? So we can stop here. Now let's look at the second question, which is 1.2. Right, so question 1.2 says we need to determine the coordinates of n, right? So the coordinates of n, and they give us a clue here that coordinates of n should be the midpoint of QS, right? So this is QS, right? So this will be your QS, and then the midpoint of QS will be your n. So your n will be here, right? So in order for us to do that, we are going to use the midpoint formula or the midpoint theorem, right? So the midpoint theorem or the midpoint formula is usually given by x1 plus x2 all over 2 and y1 plus y2 all over 2, right? So remember we are dealing with the midpoint of QS, so we are going to use the coordinates of QS, right? So your Q is given by 4 paired with 1, and your S is -2 minus 1, right? So let's see if we substitute what answer we get, right? So from here, we can just say this is gonna be our x1. We can just say this is gonna be our x1, x2, nope, y1. Let's just write it neatly, x1, y1, and this is going to be x2, y2. Great. So now we can simply say n is equals to x1 plus x2. So that's going to be your 4 plus minus 2. So it's going to be your 4 plus minus 2 all over 2, comma, and then your y1 plus y2, that's going to be your 1 plus minus 1, right, all over 2, right? So now n is going to be equals to, we can simplify there, so 4, your negative times positive is going to be negative, so it's going to be 4 minus 2, which is 2 divided by 2, and then you have your 1 minus 1, because negative times positive, it's going to be negative, so you have 1 minus 1, which is 0 all over 2, and then now you are going to have 1 and 0. So these will be your coordinates of n, right? So these will be your coordinates of n, right? So now we are being told to prove, let's look at 1.3. We are being told to prove that Pn, right? Pn, right? Remember, we still have we still have n. So we are being asked to prove that Pn, which is going to be this line, is perpendicular to QS, right? It's perpendicular to QS, right? It's perpendicular. So what we want is to know if these lines, your Pn is perpendicular to QS, right? So in order for us to do that, right? In order for us to do that, for anything or for any line to be perpendicular to each other, the product of their gradients, so the product of their gradients should be equals to -1. So the product of their gradients should be equal to -1. So in mathematics terms, this will be your m1, this will be your m1 times your m2 equals to -1. So we need to prove that the gradient of m1, it's gonna be the gradient of m1, when you multiply it by the gradient of m2, it's going to give us -1. So in simple terms, we can simply write this as your m, right? So it can be your m for, remember, it's going to be your n for Pn times your m for QS, right? It should be equals to -1, and if these are equals to -1, then this will be proven to be perpendicular, right? So now let's look at the gradient of Pn, right? Let's look at the gradient of Pn. Remember, the gradient is usually found by your y2 minus y1 all over your x2 minus your x1. So this will be, remember we are looking at Pn, so your P, these will be your coordinates. So let's look at the y for n. So y for n is going to be 0, and then the y for P is -3 all over, what is x for P? So x for n is going to be 1 minus, what is x for n? So x for P, so x for P is 0, right? So we can just continue here. let's move this here. So your m for Pn is going to be 0 minus 3, it's negative 3 over 1 minus 0 is just 1. So this is going to be equals to negative 3. So your MPN is equals to negative 3. Right. So now let's find your M for QS, right? And for QS, so this is going to be your Y for Q minus your Y for S all over your X for Q minus your X for S, right? Remember, what were the coordinates? The coordinates were, you can just look over here. The coordinates were your Y for Q is 1. Your Y for Q is 1 minus your Y for S is going to be minus 1 over your Q is going to be, your X for Q is going to be your 4 minus 2. Right, so now you have your MQS is going to be your 1, negative 1 times negative 1, it's going to be your plus 1 all over your 4, it's going to be your 4 plus 2, so this is going to be your 2 all over 6, right? So what is 2 over 6? So 2 goes once here, and then it goes thrice here, and then you'll be left with M is equals to, equals to 1 over 3. So now you have your M QS is equals to 1 over 3, right? And then now, in order for us, remember we had this, and now we also have this. Now, in order for us to prove that these lines are perpendicular, remember what we said. We said your MPN times your MQS should be equals to negative 1, right? So negative 3 times 1 over 3 is going to give us negative 1, right? Is going to give us negative 1 because this 3 goes here once, it also goes here once, and then you will be left with your negative 1 equals to your negative 1, right? So therefore these lines are indeed perpendicular to each other. So this is what we can do. We can just create some space. We can just create some space to write there to conclude, right? And therefore your therefore we can just say your P N is indeed perpendicular to QS. Why? Because the gradient of Pn times the gradient of QS is equals to negative 1. Right. Great. Perfect. So now let's look at another question, right? So now let's look at question 1.4, right? Right, so if we are to look at 1.4, right, if we are to look at 1.4, so we are being told, or we are being asked to prove that P, right, P, N, and R are collinear, right? So the first thing that we need to understand about collinear, right? So collinear, it's 3 or 2 or more points that lie on the same line, right? So your collinear would be defined by 2 or more points that lie on the same line, right? So if we come back here, they are telling us that we have to prove that Pn and R are collinear. So we already have N. Remember what was N? N was the midpoint. So this is what we are required to prove, right? And then you have N. So in order for us to prove that, right, we are going to have to prove that the gradient of Pn is equals to the gradient of Nr, right? So in order for us to prove, right, to prove that P, R, and N, right, are collinear, right? That means that they are gradients, right? So the gradients, which is the gradient of P n, should be equals to the gradient of n r. Right, so remember we already have the gradient of Pn because we found it. So the gradient of Pn was, what was the gradient of Pn? The gradient of Pn was -3, right? So the gradient of Pn, it was already proven to be equals to -3, right? So what we need to find is the gradient of Nr. Right, so we need to find the gradient of Nr, right? So this is going to be your y r minus your yn all over your x of r minus your x of n, right? Remember what is r? So your r is going to, your y of r is going to be -3. What is your y of n? Remember your y of n. What was your y of n? N is 0, n is 1 and 0, right? So n, the coordinates of n is 1 and 0, right? So your y of r is -3. What is your y of n? It's just 0 all over your x of r. It's going to be your 2 minus 1. Right, so now you have -3 minus 0 is -3, 2 minus 1 is 1, and then this is going to be -3. So therefore the gradient of Pn is indeed equals to the gradient of Nr, which is equals to -3, right? And so therefore P, R, and N are collinear. Right, so now let's look at 1.5. Right, so now let's look at 1.5. So what kind of a quadrilateral is PQRS? Right, what kind of a quadrilateral is PQRS? So remember we had proven that we had already proven that, right, these lines are perpendicular to each other, right? And you have your n. Remember we'd already proven that these lines are perpendicular to each other, and also that this is equals to this, right? Your PR is equals to your QS, right? So we already had your P, right? We already know that your Pn is perpendicular to QS, right? And we also know that your PR is equals to your QS, right? So what kind of a quadrilateral gives us the lines that will be perpendicular to each other and also equal, right? Because remember that also we know that your n is midpoint of QS, right? So that would mean that these diagonals, right? It means that these diagonals, these two diagonals bisect at right angles, right? So these diagonals, which is your P, R, and QS, they bisect at 90 degrees, and therefore this will be a kite, right? So therefore this will be a kite, your P, and therefore your PQRS is a kite, is gonna be a kite, right? So maybe let's just put it nicely, so without turning the page. So let's just put it here, right? So we can therefore say that your PQRS is a kite, right? Why? Because we know that your PN is perpendicular to QR, and we also know that your PQ is equals to QS, and then we also know this, right? And this would mean that your PR and QS, they bisect at 90 degrees. So hence this will be your kite. Great. So now let's look at question 2. Right? So question 2, they are saying in the diagram below, A, C, and D are vertices of triangle ACD, right? Of triangle ACD. Great. So they are calling this triangle ACD. So this would be your ACD. Great. So they are telling us that CA intersects the y-axis, right? As we can see. So your A is probably here, right? And we are also we were told that triangle ACD, so we are just going to construct a line to here, right? And we're going to call that line AD, right? So this is a constructed line. So let's just do it neatly. Great. And then CA intersects the y-axis, which is going to be a point here at F, right? So this is going to be point F, and CA cuts the x-axis at G, which we can see G here. So straight line DE, right? DE is drawn parallel to CA, so both CA and DE are parallel, right? And then we are being told that CFO, right? So CFO, so this would be your CFO. So this is what they're talking about. So let's just write F here, right? And then CFO, so CFO would be this line. Would be this angle, right? Great. So they are saying that this angle is alpha, right? This angle is alpha. So now we can go ahead and solve our problem, right? So the first problem being 2.1, right? So what they are looking for in 2.1, they are looking for calculate the gradient of line A C, right? So the gradient of line AC, so this would be your gradient, right? So remember, you have your AC and your A being -3 and 2, and then you have your C being 9 and 10, right? So this can be your x1, y1, and then your x2, y2. And so we are being asked to calculate the gradient of AC. So the gradient of AC will be given by your y of C minus your y of A all over your x of C minus your x of A. Right, so when we substitute, we are going to have what is your y of C. Your y of C is going to be your 10 minus 2 all over your 9 minus 3. So this is going to be 8 all over, this is going to be plus 3. So 9 plus 3 is 12. So 8, the common factor, or the common factor would be 2. So no, it would be 4. The highest common factor would be 4. So 4 would go here twice, and then it would go here thrice, right? Therefore your gradient is going to be your 3. It's going to be your 2 over 3. So now you have solved question 2.1. So now let's look at 2.2. Determine the equation of the line in the form of they want the equation of line DE, right, in the form of y is equals to mx plus c, right? DE, right? So let's look at DE, right? DE. So this is DE, right? So this would be your DE. Let's just maybe try to highlight DE. Let's use a different color. So this will be your DE. Right. So now what they want is very simple. What they want is they want the equation of DE. But remember what we were told, right? We know that DE is parallel to AC. And what does that tell us about the gradient? It means that the gradient of DE will be equals to the gradient of AC. Right, and since we have the gradient of AC, this will be equals to your 2 over 3. So this is very important. This is very important because we don't have to recalculate the gradient since we already had it, right? So now what we are going to do is we have our equation now with 2 over 3. Going to be your 2 over 3x plus c, right? So now we can use any coordinate, right? We can either use D or E, but since we only have D, we are just going to use D. So we are going to use D, and D is 4 and 2. So if D is 4 and 2, no, it's 4 and minus 2. Should be 4 minus 2. We can just substitute. Remember, this will be your x, and then this will be your y. We can just substitute x and y to find c, and then we will have our equation. So y is going to be minus 2 equals to your 2 over 3 into what is x, it's 4 plus c, right? So this is minus 2 equals to your 2 times 4. Your 2 times 4 is 8 over 3. Right? So your 2 times 4 is 8 over 3 plus c. And then you will have your c as minus 2 minus 8 over, it's going to be 8 over 3. Right? So here, you can simply punch your calculator. You don't have to stress yourself about this. They didn't tell you to not use a calculator. So this is going to be your 14 over 3. Therefore, your equation is going to be your y is equals to your 2 over 3x minus 14 over 3. So this will be your equation, right? And then now we are being told to calculate the size of alpha, right? So this is alpha. Remember, this is alpha. So in order for us to do that, remember we have the gradient of AC, right? We have the gradient of AC. That would be your 2.3, right? So we have the gradient of AC, which is equals to your 2 over 3, right? And remember, the equation for finding alpha we are going to use is m is equals to your tan theta. So in this case, tan theta is going to be your tan alpha, right? So this is going to be your MAC tan of alpha, right? Remember, we want the equation. We want alpha. So we have 2 over 3. Right, so we are going to have 2 over 3 is equals to your tan alpha, and therefore your alpha is going to be the tan inverse of 2 over 3, and that will give you approximately 33.69 degrees if you punch your calculator. So this will be your answer, right? So this will be your answer. So you would have gotten your 3 marks here. Right, so now let's look at 2.4. So now in 2.4, they are saying B is a point on the first quadrant such that ABDE in that order forms a rectangle. Calculate with reasons, giving reasons, the coordinates of M, which is the midpoint of BE. So here, we might need to erase here, right? So what we need here, or what we are being told, they are saying that B is a point on the first quadrant such that ABDE in that order forms a rectangle. So we have to form a rectangle, and B is going to be a point in the first quadrant. So this will be your first quadrant, right? So that means that your B, we can just make B to be here, right? And then this will be this line and this line, and then we are going to have to construct this, and then you will have this line as well, right? And it's parallel, right? So maybe we can just use a different color here for the diagonals. Right, so now in this order you have your A, B, D, E. Great. You have your A, B, D, E forming a rectangle. So now we have to calculate, giving the reasons, the coordinates of M, right? So the coordinates of M, which is the midpoint of BE. So this means that your M will be here, right? So obviously, in order for us to be able to calculate the coordinates of M, which is the midpoint of BE, we are going to have to use the midpoint formula, right? 2.4.1. And what does the midpoint formula say? It's x1 plus x2 all over 2, and your y1 plus your y2 all over 2, right? So now remember, for a triangle, not a triangle, for a rectangle, right? For a rectangle, in order for us to do that, remember we don't have the coordinates of BE, right? But we can use the coordinates of AD. Why? Because BE and AD bisect at the same point, right? Or they intersect at the same point, right? So your AD and BE, they intersect. So they intersect at M, right? And therefore we can use AD, right? So that means that in order for us to find the coordinates of M, it's going to be going to look at A, right? And your A is -3 and 2, and your D is your 4 and -2. So this is your x1, y1, your x2, your y2. Therefore this will be your M, equals to, so what is x1? X1 is going to be -3 plus 2 all over 2, right? Is it minus? Yeah. Are we correct? Yeah. No. I was thinking that how are we getting a negative x value already? Because if this is 2, then it would have been a negative. So now it's going to be a positive, right? So now we want your y2, y1 and y2. So that's going to be your 2 plus y2 is -2, right, all over 2. So now you are going to have -3 plus 4, it's going to be 1, all over 2, and negative times positive, so this is going to be negative, so 2 minus 2 is going to be 0 over 2. So therefore this is going to be just 1 over 2 paired with 0, right? So that's going to be your midpoint, right? So now let's look at 2.4.2, right? So they want the diagonal of BE, the length of the diagonal BE, right? Remember, we don't have the coordinates of B and E, right? But we have the coordinates of A and D. And what do we know about diagonals of a rectangle? So the diagonals of a rectangle are equal, right? So the diagonals of a rectangle are equal. So that means that the length of BE should be equals to the length of AD, right? So that means that if we use a distance formula to find the distance of AD, then we would have found DE, right? So let's do that, right? So you have your A, so your A is going to be, what was our A? Our A was -3 and 2, -3 and 2, and your D is 4 and -2. Your D is 4 and -2, right? So we can somehow use a distance formula, which is going to be your AD, right? So this is going to be your x2 minus x1 squared plus your y2 minus y1 squared, right? So essentially we can just call this x1 and x and y1, right? And this is going to be your x2 and y2, right? So now your AD is going to be, what is x2? It's going to be your 4 minus 3 all squared plus y2, it's -2 minus 2 squared. So AD is going to be, this is going to be 4 plus 3, which is going to be your 12 squared. And then 2 minus 2 is going to be 0, so it's going to be minus plus 0. And then your AD is essentially going to be your 144 squared, which is the same thing as 12. So therefore your AD is equals to 12 units. But remember, what do we want? We want the length of diagonal BE, right? So therefore your BE is going to be 12 units as well. Why? Because as we already said, right, the diagonals of a rectangle are equal. Great. So now let's look at question 3. All right, so question 3, let's do this. So question 3.1, right? So they're saying sketch the graph of y. We need to sketch the graph of y is equals to 3 over x minus 2. I'm showing the asymptotes and the intercept with the x's, right? So already when I see this type of an equation, I can tell you that this is a hyperbolic equation, right? Remember, the standard form of a hyperbolic equation is y is equals to a over x minus p plus q, right? So your value of p would represent your horizontal asymptote, and then the value of it should represent your vertical asymptote, and then the value of q will represent your horizontal asymptote, right? Great. So now in this case, right, we are given we are going to try and write this equation in that form. So it's going to be y is equals to 3 over your x minus 0, right? Minus 2, right? So this means that our x minus 0 equals to 0 is going to be x is equals to 0. So that's going to be our our vertical asymptote, right? And then your y is just going to be y is equals to minus 2, right? So your asymptotes is going to be 0 and minus 2, right? So now remember the value of a tells us something as well. So the value of a, since the value of a is greater than 0, so the value of a is greater than 0, that means that our graph will be on the first and third quad, which is first and third quadrant, right? Great. So now let's find the intercept of the graph, right? So that's the next thing that we need to do. Remember, we have our vertical asymptote, which is equals to x is equals to 0, and then we have our horizontal asymptote. Our horizontal asymptote is y is equals to minus 2, right? Now we want the x-intercept, right? So we want the x-intercept. So in order for us to find the x-intercept, right, that means that our y should be equals to 0, right? So for x int, it means that our y should be equals to 0. So it's going to be 0 is equals to 3 over x minus 2, right? So it's transpose, so this is going to be 2 is equals to 3 over x, right? And we can simply multiply, cross multiply. So cross multiplication is going to give us x is equals to your 3 over 2, which is just 1.5, right? And then now what is left is your y-intercept. So this was your x-int. So now we need our y-int, our y-intercept, meaning that our x now should be equals to 0. So you will have your y is equals to 3 over 0 minus 2, right? And then your y is going to be equals to minus 2, right? So your intercepts, your graph will pass through, right? When x is 0, it's going to be negative 2. And then here, you can just write it with, okay, this is intercept, and then here it's going to be your 1.5 and 0, right? So this is another intercept, right? So now we have our points, right? So now we have our valid, or we have our important points, right? So we have our important points. Then we can go on and draw the graph. So in order for us to draw a graph, so this will be just a rough sketch of the graph. So this will be a rough sketch of the graph. Let's not make it bigger. So this will be your y, and then this will be your x. So we are going to start with our asymptotes. So the first asymptote is x is equals to 0. So this is gonna be it, right? So x is 0. And then now, where does the other asymptote cut? It cuts at negative 2, right? So this is where, so you can just have your minus 1 and minus 2, right? And then you're gonna have 1, 2, 3, 4, 5, then just 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 3, negative 4, negative 5, right? Great. So now our horizontal asymptote is cut at y is equals to 2. So this will be your horizontal asymptote where y is equals to -2, right? And then the other one, it's just going to be here, right, where x is just 0, right? And then what's our x-intercepts, your intercepts? So when y is 0, it's -2. So when x is 0, right, our graph will pass at -2. And then also when our x is 1.5, so our 1.5 will probably be here, right? Our 1.5 will probably be here, and it's 0. And then the other one is, yeah, so the other one is y is equals to -2. So at some point it will touch the graph, right? So we don't have to really write it. So we can just stop it here. And then this is how our graph will look like. So let's just use a different color to draw the graph. So the first graph will look like this. Going there. And then the other one will just be here. Oh no. The other one will just be like this. Right, so here you would have drawn your graph, which this you can just call it your y and your y. Right, this is your graph. And then now let's answer the questions that we are being asked. So your 3.2.1, so they want a vertical asymptote. 3.2.1, the vertical asymptote is going to be x is equals to 0. Remember, this is the vertical asymptote, right? This is the vertical asymptote. And then they want the horizontal asymptote, 3.2.2. 3.2.2, they want the horizontal asymptote. The horizontal asymptote is y is equals to -2. Right, and then 3.3.3, the graph that would result if you shift this graph, if we shift the graph 2 units up. So if we shift it 2 units up, remember, this is how the graph is always represented. So it's 3x -2. So if we shift the graph, what are they saying? If we shift the graph 2 units up, so in order for the graph to shift up, it's going to affect our value of q. So it's going to be +2. And then if it shifts 2 units to the right, 2 units to the right. So what would be your 2 units to the right? It's going to be -2 here, right? So this is going to be +2. This is going to be -2, right? So now your graph is going to be your 3 over x -2. So this is how your new graph will be looking like. Right, so they say the 3.3 writes the x-intercept of the graph. So the x-intercept of the graph, so maybe what we can do is just take this up, because I believe that we have enough space. The x-intercept, it's not something that would need a new page. So now your 3.3, they want the x-intercept of the graph. So the x-intercept of the graph, wait, let's see. Yeah, the x-intercept of the graph, right? Wait. Here, I think we may have, let me see something. Your y-intercept, I just want to confirm something. Your y-intercept, it means that your x should be 0, right? Your y-int, it means that your x should be 0. So if your x is 0, okay. So in this case, our y-intercept, it should be undefined, in fact, right? It should be undefined, and the reason why it would be undefined, it's because the graph cannot touch your vertical asymptote, right? So here, what we ought to have had, I may not be missing something. I may be missing something. Let me see. So they want that x, right? Or the x-intercept of the graph. So we have the x-intercept of the graph, which is 1.5 and 0. Apologies for that. So it's gonna be your 1.5 and 0. That's going to be your x-int. Great. So now let's look at question 4, right? Let's look at question 4. So in question 4, it's a functions problem. What we have here, they're telling us that the graphs of f of x, which is f of x minus 2, which is the straight line graph, and g of x, which is the parabola, are given. The graph intersected A and Q, right? So this is where the graphs intersect. This is where the graphs intersect. And A and B are the x-intercepts of G, right? So they've also confirmed that this is your x-intercept and this is your x-intercept. Right, so let's look at 4.1. So in 4.1, they are telling us that we need to determine the length of AB. Right, so what we need is this distance, right? I mean, the length, right? The distance from here to here. Right, so in order for us to do that, remember we are told that A and B are x-intercepts, right? And if we look at g of x, so this will be your g of x. If we find the x-intercept of g of x, then we'll be able to find the coordinates, and then we'll be able to find the length, right? So we are going to use g of x, right, which is x squared minus 6x minus 16, right? So we want the x-intercept. So for x-intercept, right, it means that your y is going to be equals to 0. So if you equate 0, you are going to have x squared minus 6x minus 16. Right, so this is going to be now a difference of 2 squares. So what are the factors of negative 16 that will give you a negative 6, right? The factors that I can think of, it's 8. It's 8 and 2, right? So which one has to be positive and which one has to be negative? So minus 8 plus 2, it's going to give me negative 6, right? So here I can just say plus 2 minus 8, which is x, and therefore my x is going to be minus 2, or x is going to be minus, it's going to be 8, right? So now I can decide, right? So your a, because a is in this second quadrant, your a is going to be minus 2 and 0, and then your b will take on the positive value, which is 8 and 0, right? So therefore in order for us to find the length, so AB is gonna simply be 8 minus minus 2. So your AB now will be equals to your 8 plus 2. So AB is going to be your 10 units, right? Great. There is, yeah, we are focusing on the x values, right? So if we subtract them, then we would have the length of AB. Great. So now let's look at 4.2, right? So 4.2, they are saying they want the coordinates of Q, right? So coordinates of Q is an intersection of G and F, right? So Q is an intersection of f of x and g of x, and if they intersect at the same point, we can simply say g of x is equals to your f of x, and then we are going to solve from there. So your g of x is x squared minus 6x minus 16 equals to minus x minus 2, right? We are solving for x now. Remember, we want the coordinates of Q, so we are going to solve for x. So it's going to be x squared minus 6x plus x minus 16 plus 2 is going to be equals to 0. So your x squared minus 6x plus x, it's going to be minus 5x minus 16 plus 2, it's going to be minus 14 equals to 0, right? So now I need the factors of 14. I need the factors of 14, right? That will give me a negative 5. So that's going to be 7 and 2. So which one has to be positive? Which one has to be negative? So this one will be negative and this one will be positive, and minus 7 plus 2 is minus 5, right? So therefore you will have your x minus 7, your x minus 2 equals to 0. So your x is going to be equals to 7, or x this is plus 2, or x is equals to b minus 2, right? So we need to choose one value. So x at q, so x here is going to be positive, right? So therefore your x is going to be equals to 7, right? So that's the value of x that we are going to choose, right? So this one we are not going to take it. So now we need the value of y, right? So we can substitute x is equals to 7 into the simplest equation, which is the straight line, right? So your y, so remember we have y is equals to minus x, right? Minus x minus 2. So minus x minus 2, and we already established that x is minus 7 minus 2. So y is going to be minus 7 minus 2 is going to be minus 9. And therefore the coordinates of q is going to be your 7 and minus 9. So these will be your coordinates, right? I hope that's very understandable. So now let's look at 4.3. So they're saying show that the coordinates of the turning point. So this will be your turning point. This is where your turning point will be. Let's show that the coordinates of the turning point are 3 and negative 25. So we are at 4.3. We need to show that the turning point is 3 and negative 25. Right? So remember, we are talking about the turning point of a parabola. It's a turning point of a parabola. Right. So if remember, we have a standard equation for a turning point of a parabola, which is given by x is equals to minus b over 2a, right? X minus b over 2a. So remember, we have your g of x is equals to, what is our g of x? X squared minus 6x minus 16. X squared minus 6x minus 16. So in this case, we need the value of a and b. But remember, your standard equation for a parabola is gonna be your ax squared plus bx plus c, right? So that means that our a value, so that means that our a is gonna be equals to 1 and our b is gonna be equals to negative 6. B is gonna be equals to negative 6. So therefore we are going to say x is equals to minus 6 all over what is 2, what is a is going to be equals to 1. So x is equals to, that is going to be positive 6 and 3. So this is going to be 2. So you have x as being 2, right? And therefore now we need y, right? Therefore we need y. So y, remember, it's going to be x squared minus 6x minus 16. So we can substitute 2 here. So it's going to be x squared. It's going to be 2 squared, right? This is not supposed to be 2. It's supposed to be 2 here. And then here would be 3. Right. So now this will be 3 squared minus 6 into 3 minus 16. Right. So you have your y is equals to 9 minus 18 minus 16. Right. So this is going to be 9 minus 18 minus 16. So this is going to be negative 25. So therefore your turning point, which makes sense, so therefore your turning point is going to be your 3 and negative 25. So this is going to be your turning point, right? And it makes sense because here your y is going to be negative. So here your y is going to be negative, and your x is going to be your positive. So it makes sense. So now let's look at your question 4.4. So we are going to look at where your F intersects your G. So this is how usually we have to look at it. So your F intersects here at F and G, they intersect at both A and Q, and we already found the values of A and Q. So now we want the values of X for which your F will be greater than your G, right? We want the values of X that will make F be greater than G, right? So it's very simple. So from just inspection, right? From inspection, all the values that are here, all the values of X that are here will make f be greater than g, right? However, those values, that value should not be, so this is how you would make it. So those values, they will be in this range, right? So it's all going to be those values, right? So it means that your x is going to be greater than -2. All the values that are greater than -2 will be here, right? But not less than 7, right? From just inspection, right? So you already have your answer as that. So that should be what? It should be 4.4, right? It should be 4.4, right? Let me repeat this, right? Let me repeat this. So what we want is, we want to know first where your f intersects g, right? So they intersect here, right? They intersect here. So we want the values of f for this graph that will be greater than the values of g, right? Values of x. So we already know, we already found the coordinates. So all the values that are within this region, right, will make f to be greater than g, right? You can even test it with your calculator, right? And then all the values that are below, that are here, will make f be less than g. So that's how usually you get it right, right? So it's going to be all the values that are between this range that are going to make f to be greater than g, and anything that's here will make f be less than g, right? So that's how we are going to write it. Remember, we know that it's going to be n7, right? Where is 7 coming from? 7 is coming from q. This is the 7, and then that's the -2 that we found here, the x-intercepts. So remember, here you have your q as your 7 and -2, I think, and then here you have your -2 and 0. Let's just confirm. No, it's 7 and 9. 7 and -9. Yeah, 7 and -9. So now let's look at the last question. For which value of k, and then they give us an expression, we'll have 2 equal roots, right? So in order for us to have 2 equal roots, right, this is it taking us to a discriminant. So let's just write this equation. So it's going to be 4.5, right? So you had your x squared minus, let's see, it's x squared minus 6x plus k plus 4, minus 6x plus k plus 4 equals to 0. If you remember well, during our class, right, the first semester when we were doing exponents and sets, and we moved to equations and equations and inequalities, right? In order for us to have 2 equal roots, that would mean that our discriminant should be equals to 0. Right? That's the easiest way we can find the value of x that will make k to have, that will make this equation to have 2 equal roots. Remember what the question is saying. Determine for which value of k, right? The value of k, not the values of k. So we are going to consider 1, right? But it could have been any value that is greater or equals to 0. So they are saying determine for which value of k, right, will will this equation give two equal roots, right? So in that case, if we make that discriminant b equals to 0, then we will be able to solve for k. Remember what the discriminant is. Discriminant is b squared minus 4ac equals to 0, right? So in this case, your b will be 6, right, which is essentially negative 6 squared minus 4, what is going to be your a1, and then your c is going to be everything here, right? So that's going to be your k plus 4, right? So as you can see how I wrote it, because I've seen many students making mistake and they would only choose a 4, right? And then from here you are going to have a 36 minus 4 into k plus 4 equals to 0, and 36 minus 4k minus 16 is equals to 0, and then 36 minus 16, it's going to give us 20. So we are going to have minus 4k is equals to positive 20 equals to 0, and we say more, then we can just divide by negative 4, and then this and that will cancel, and then we'll have k is equals to 5. So this is the value of k that will make us to have two equal roots here, right? You can even test this to see if you do have equal roots. So you can test it for interest's sake. So you are going to have x squared minus 6x plus 5 plus 4 is equals to 0, and then x squared minus 6x plus 9 is equals to 0. So remember, roots are just values of x, so it's going to be x, it's positive, so this is going to be minus 3, so x is equals to 3, or x is equals to 3. So both these roots, are equal, right, if k is equals to 5, right? So you don't really have to do the test, but this is where you can end, right? So now let's look at another equation, another problem.